Energy is the major source for the economic development of any country. In recent years, India's energy consumption has been increasing at a relatively fast rate due to population growth and economic development. Energy plays substantial role in economic growth, hence, relationship between energy consumption and economic growth is an important issue for economists. India has rich resources of fuels like coal and natural gases. The fuels, including fossil fuels like coal, petrol, diesel, were in demand traditionally and are still in wide use. When we burn fossil fuels like coal and gas to create electricity or power our cars, we release carbon dioxide pollution into the atmosphere. When vegetation is removed or burnt, the stored carbon is released back into the atmosphere as carbon dioxide, contributing to global warming. Up to 1/5 of global greenhouse gas pollution comes from forest degradation. Animals, livestock like sheep and cattle produce methane, a greenhouse gas. Some fertilizers used by the farmers release nitrous oxide, which is another greenhouse gas. All these gases contribute to global warming. Earth receives some of the radiant energy, light and heat from the sun. The infrared heat part is trapped in the atmosphere, is responsible for global warming. Whenever energy balance is shifted, Earth's surface becomes warmer or cooler, leading to a variety of changes in global climate. It is high time now to move towards clean energy. Renewable energy is one of the environmentally friendly sources of energy and has been identified as a key tool to counter climate change and enhance energy security. World over, the scientists are working towards shifting the available fossil fuel-based energy systems to low-carbon technologies like solar energy, wind energy, hydro energy, tidal energy, and biomass energies, etc. Thermal energy, which as on date covers about 75% of total electricity generated, is neither environmentally friendly nor it is clean. Therefore, it has become the government's priority all over the world to make clean energy affordable to the masses. Over the last 5 years, the Indian government is committed to double the clean energy R&D investments to take the technology to a higher level. The DBT, the Department of Biotechnology, is coordinating all mission innovation activities for India. The Indian government is on its way to execute R&D on the double clean energy.
I'm very pleased to tell you our bit about the clean energy that we are working on. All of you are aware that CSIR, the Council for Scientific and Industrial Research, has been working in many different areas in the country, areas related to science and technology and its applications to the society in general. Traditionally, energy in the country has been derived from either thermal sources, thermal power stations and all, or from hydroelectric power sources. Now, both of these have pros and cons in terms of amount of generation and all, but they also leave a big carbon footprint on the earth, and therefore what we have been continuously looking for are alternate energy sources which are available in abundance and do not have very negative impact on the environment in general. One of the ways to doing that is the solar way. We have solar energy available in plenty, and if we can tap that and meet our energy requirements, that will be terrific for our society. So, but it will also be environmentally friendly, it's sustainable, and it would meet all the requirements of the country in general.
Let's have a look on various types of renewable energies. Solar energy. Of the various renewable energy resources, solar energy potential is the highest in the country. The equivalent energy potential is about 6,000 million gigawatt hours of energy per year. India lies in the sunny regions of the world. Solar energy has been in use for a long time in India. where solar energy has been found to be very promising and has shown its significant utility. Solar panels actually comprise many small units called photovoltaic cells that convert sunlight into electricity. Each photovoltaic cell is basically a sandwich made up of two thin layers of different types of semiconducting material, usually silicon. Many cells linked together make up a solar panel. These solar panels are installed for high voltage power generation. When a solar panel is directly under the sun, light rays shine on it and it works with its full potential, but as the sun moves its position during the day, the same panel which was synchronized otherwise comes under the shadow and its power generation capacity drops substantially. That is why it requires a large area of land or roof to generate a small amount of power from these solar panels, and they are supposed to be put in the direction of sun rays at different times of the day. However, to solve the problem related to requirement of large land area, CSIR scientists have developed a unique design of a solar tree. The solar power tray is designed for utilizing minimum land to harness maximum solar energy. Smart solar trays have been developed and installed by CSIR. This occupies only 0.25 meter square of ground space and is a decentralized power generation system which can be scaled and configured according to the location and is in line with the Smart City mission of the Government of India. Solar power tree rotates on its axis with all the solar panels together in the direction from east to west that generates 10 to 15% extra power from the sun rays. In India, the per capita consumption of electricity is only about 1/4 the world average. So a vast growth of the power generation system network is needed for the next several years to supply the energy to all households in a reliable manner. Hydroelectric cell. Another clean energy innovation has been reported recently is hydroelectric cell, which simply works on a very small volume of water molecules. Here, the water molecules are broken into ions and do not harm the environment. Dr. R.K. Kotnala, former chief scientist, and his research partner, Dr. Jyoti Shah of National Physical Laboratory, have successfully invented a unique device called a hydroelectric cell, which is eco-friendly. Hydroelectric cell generates electricity by sprinkling few drops of water. For making of hydroelectric cell, the team synthesized novel nanoporous lithium-substituted magnesium ferrite. Lithium magnesium ferrite is used to split the water molecules into hydronium and hydroxide ions spontaneously without using external energy, light, acid or alkali and electrolyte. Zinc and silver electrodes act as anode and cathode to separate and collect ions to produce electricity. In the hydroelectric cell, a pelleted material is sandwiched between zinc and silver electrode, where zinc plate is fixed to one side of material pellet and the other side a particular comb pattern is printed using conducting silver paint. As of now, hydroelectric cells are made in the range from 1 inch to 4 inch pellet. Electrodes are wired so as to complete the circuit. Each magnesium ferrite of 2 inch diameter cell is able to produce 110 milliampere current and 0.9 volt. The capacity of electric current generation can be increased simply by connecting multiple hydroelectric cells in series and parallel combination to obtain the desired output power. Successful demonstration on working on small electric appliances has already been done. The hydroelectric cell has multiple advantages over its existing equivalents in portable batteries and mainstream energy generation.
Hydroelectric cell has a potential to replace not only solar cell but fuel cell also, as its cost being low and it is all make in India in totality. We are approaching to industries as well as to the government so that soon we can bring hydroelectric cell into market. In future, electric vehicles are to be used for transportation purpose. Then the hydroelectric cell can be used as a main source of power to a electric vehicles.
Fabrication of hydroelectric cell is so simple and cost effective that it can be used in rural areas where the transmission line cost is very high. It can also be used in remote areas where military persons resides. It is very portable and lightweight that anyone carry with their travelling kit to charge their mobile or any small power device.
In India, mission innovation has not only been supported or governed by nodal agencies like DBT and CSIR, but several other private organizations like TERI, who are committed to their goals of producing energy from non-conventional resources and thus helping in environmental protection. However, TERI, the Energy and Resources Institute, New Delhi, is doing a remarkable work in the process of developing various methods of clean energy sources. TERI has developed biomass gasifier for generating productive energy. Biomass gasification is a process of converting solid biomass fuel into a gaseous combustible gas through a sequence of thermochemical reactions. Almost 2.5 to 3 normal cubic meter of gas can be obtained through gasification of about 1 kg of air-dried biomass. This technology is slowly replacing both traditional biomass use and fossil fuels powered systems, as it provides an excellent decentralized source of energy at an affordable cost. Apart from rural households, biomass fuels are the main source of energy to a large number of small, rural and cottage industries. Biomass energy. The most prevalent source of energy is biomass. Biomass is biological material derived from living or recently living organisms. TERI has developed different models of forced draft biomass, clean cooking stoves with solar power, which not only reduces the smoke but also reduces the consumption of firewood. Significant results were observed when these smart clean cooking stoves were promoted in rural area of Bihar in a joint initiative of TERI, Power Finance Corporation, Agriculture Insurance Company and Jivika. Cooking stove and lighting brought prosperity in their lives by bringing brightness in their dark lives, where children can study and women can do their other household chores at night and take care of their health. This will also make the country's remote areas self-sufficient from the old age system of using firewood for fuel and burning kerosene.
सोलर लाइट से हमको सूक्ष्म रोशनी मिल रहा है और रात में बच्चे लोग को पढ़ने में आसानी हो रहा है और रात में दीदी लोग सिलाई बुनाई करती है। पहले जो है हम सोनवन की जाके मोबाइल चार्ज करते थे 5 रुपया दे के डेली बाय डेली। अभी हमको घर बैठे चार्ज हो रहा है मोबाइल। यही सब फायदा ना। किरासन तेल भी यूज करते थे पहले, डिबिया और लालटेन में जलाते थे, अभी वो तेल भी मतलब बच रहा है।
At TERI we have developed very innovative design of gasifier which convert this solid waste material, bio waste material into a syngas using gasification technology, and this syngas is further being used as a fuel either for industrial heat application in furnaces, boilers and other devices which has been used to meet the industrial heat demand of our MSME sectors, and or it can be used as a fuel to run in IC engine mode to produce power both at decentralized off grid areas or for megawatt scale applications for grid applications.
Transport fuels account for about 25% of total primary energy production. crude oil imports relate to about 34% of India's total import bill. At Terry Deacon Nanobiotechnology Centre, scientists have developed a process for fuel production from algae, which has shown a great potential in clean and green energy. There is a bottom horizontal growth section similar to open raceway algal ponds. Here, a paddle wheel powered by a motor keeps algal culture flowing through channels 30 cm deep and 75 cm wide in a closed loop and keeps the culture well mixed. The overall size of the horizontal section is 6.5 meters into 3.5 meters. Above this horizontal growth section, there are vertical panels, 1 meter tall and 20 centimeter wide, with algal culture that's set up at a distance of 1 meter from each other. The sides of the vertical panels are made of flexible transparent plastic. There is a submersible pump at the bottom of each panel to prevent the algae from settling and keeping them well mixed. Partially reflective transparent sheets are placed at 45 degrees on either side of the vertical panels for additional distribution of sunlight. The algae thus harvested is in the form of a slurry, concentrated to a thick paste. This slurry, with further processing, is converted as the fuel for vehicles. The system yields 1.5 to 2.0 times higher productivity than standard system. The system has been tested at 10,000 litre capacity so far.
What we are working on is first development of an outdoor algal growth system for algal production. We see very high yields in the lab, but translating it to outdoor mass productivity has been a challenge. So we have used sunlight distribution principles in our algal system here, whereby using this system, we have found about 1.5 to 2.5 times higher outdoor productivity compared to standard systems. We concentrate the algae to a wet, thick paste, and then we try to harvest the algal lipids inside these algae. You can then process it further to transport fuels. Once you have removed these lipids from the algae, the remaining algae you could further utilize for other value product development like animal feed, aquaculture feed, and also new material science based novel material development. Because algae are superfood, you get a variety of carotenoids and omega fatty acids, pigments, amino acids from it. So all this together, you could have an integrated biorefinery kind of approach where you have multiple product stream coming out and you have each product adding value to each other for overall economic viability.
A project in Mumbai integrating the algal production system at 1 lakh litres with related downstream processes and co-product value addition, animal feed, nutraceuticals, is being initiated to demonstrate its commercial viability.
We are trying to build up a biorefinery approach as similar as the crude oil processing, so that there are multiple products. So the biofuel is a true replacement of diesel, and since it is of very high quality, it can be used as a jet fuel. That means the aviation industry can use it. Besides the normal fleets of transports, those are used across the board. There are multiple streams of industries which get benefited by this process. India is fortunate to have sea at the 3 sides of its boundaries, and that is providing us the seawater as a resource. The industries around in the sea shores producing flue gas, which is a waste or a pollutant, can be used as a resource as well. And this both resources on the wastelands around the seashore provides us an opportunity to produce energy which is much in demand, and it will be growing over a period of time for the Indian needs. This definitely will make a big contribution towards our transport fuel requirement, for which we are mostly dependent on the imports. So I think towards the self-sufficiency, this would be a very significant contribution.
Wind energy. India is a major player in the global wind energy market. Tamil Nadu, Maharashtra, Karnataka, Rajasthan and Gujarat are the key states which have been focusing on wind energy development in India. Modern wind turbine designs have significantly reduced the noise from turbines. Turbine designers are working to minimize noise, as noise reflects lost energy and output. Lack of wind or high speed of wind affects variability of power generation through wind. The other clean energy mission initiatives consist of coal dust collecting and briquetting system. A coal dust collecting and briquetting system was developed that controls air pollution in mining and industrial areas, effectively reducing health problems related to airborne dust in mining and industrial areas. A significant number of employees will be engaged in manufacturing and operation of the system in mines and other industrial areas. The clean energy is the current demand of India. This will help to save our country from pollution, global warming, natural calamities, and so on. India is running one of the largest and most ambitious renewable capacity expansion programs in the world. The Ministry of New and Renewable Energy (MNRE) has been taking several steps to ensure a clean energy future for the country. The various cleaner energy technologies will prove an alternative of the present-day energy sources in the times to come. Doubling the cleaner energy is a major step in this direction. However, they may not be the complete substitute, but a supplement for the energy production and distribution in future, so that nature smiles and blossoms with clean energy.